Hello everyone, welcome to machine learning. Today we'll talk about what is machine learning, what are different types of learning, and we'll also mention some important algorithms that will be discussed in these vlogs. So let's first start with what is machine learning. So machine learning is a branch of computer science that provides computers the ability to learn and improve from experience without being explicitly programmed. Let's try to understand this through an example. So you're asked to write a computer program to distinguish between a cat and a dog. A machine learning way to do this is to collect a set of images containing cats and another set of images containing dogs. Then you manually annotate those images by assigning them labels such as 0 for 0 to cats and 1 to dogs. Then you use a set of algorithms, machine learning algorithms, to train your classifier to distinguish between these two sets of images. Your performance is measured in terms of a new image being accurately classified into one of these categories. Within machine learning, there are two ways to solve this problem. The first one is to extract visually identifiable features or attributes and create feature vectors which can then be used to train classifiers. So these attributes can be skin color, appearance of whiskers, size, shape, color of nose, ears, eyes, etc. And once you extract these features, you can train any conventional machine learning algorithm such as sport vector machines, random forest, to obtain a classifier that identifies these set of images. More recently, deep learning has emerged as a way of automatically extracting feature representation from these data sets to train classifiers. So by that I mean, in conventional machine learning, you had to identify what kind of features you might need to train a sufficiently good classifier. And the measures of goodness we'll talk a little bit later. But you had to manually come up with set of features that you think might be good classifiers. But what are the best set of features? How many of those you need? This kind of information was not available. So deep learning is a paradigm shift in this thinking, that instead of extracting features manually, let the algorithm figures out what are the key features that might be important for distinguishing these two animals. So in a nutshell, machine learning is a way to teach computers to do certain tasks, for example cat versus dog classification, automatically. And this can be done in two ways. The first way is to manually extract the features and train classifiers to do this task. The other way is to automatically learn the features. We will discuss both types of algorithms, conventional machine learning as well as modern representation learning and deep learning algorithms in these vlogs. With this introduction, let's move on to the data terminology that is commonly used in machine learning literature. So there are three types of data. One is training set, validation set, and testing set. So training set includes set of examples that are used to train a machine learning algorithm. So you are given a set of dog and cat images and they are manually annotated as 0 or 1. And you train your system using this data set. Validation set is used to evaluate the performance during training to estimate the best set of hyperparameters. So when you train a machine learning algorithm, there are various set of hyperparameters. For example, if you are aware of neural networks, then how many number of hidden layers are required, what are the number of neurons in each layer, and so on and so forth. To identify the optimal set of hyperparameters, we use a validation set, which is similar to the training set, and you have its labels available. The testing set, however, contain those images which are not presented to the machine learning algorithm during training or validation. So they are completely unseen images, and the performance of the model is evaluated on this test set. Now, what are different types of learning? So there are three major types of learning. One is supervised, unsupervised, and third one is reinforcement learning. In supervised learning, both training examples and their labels are provided. So labels are usually manually generated, as I said previously, that you manually label dog and cat images as 0 and 1, and then you give to a machine learning algorithm for training. That is supervised learning, that you know what should be the correct output, and then you train your classifier to produce that correct output. In unsupervised learning, however, you don't have the output labels. You are only provided the input data. Let's say you are provided only with dog and cat images. You do not know the labels. Then the task of machine learning algorithm is to automatically identify the patterns that are distinguishable between various classes. So popular example of supervised machine learning is neural networks. So they are supervised, they come under supervised machine learning algorithms. And in unsupervised machine learning, K means clustering, density estimation, and other kind of stuff comes in. Reinforcement learning differs from these two in the sense that no output is provided, but there is a goal to satisfy. For example, the game of chess. In the game of chess, the desired reward is win, and reinforcement learning finds suitable actions to take on the chessboard to maximize the reward. So whatever move the even every single move has its own reward, and out of all the possibilities, which move gives you the maximum reward or brings you closer to the win, that move is chosen. So this is mostly based on trial and error, and the computer system automatically learns to maximize that reward. So a popular example of this is Q learning. So now let's talk about what are the various algorithms that we will cover during our discussions. We'll start with the basics, which will include probability and information theory. These are the prerequisites for understanding any machine learning algorithm, and we'll spend considerable amount of time on these basics. And with this knowledge, we will be able to move towards understanding generalized linear models for regression and classification. These will include linear discriminant analysis and so on, logistic regression, and so on and so forth. And then we'll discuss about feed-forward neural networks, various regularization techniques and optimization algorithms for training neural networks. And with this understanding, we'll be able to better appreciate convolutional neural networks, long short-term memories, and recurrent neural networks. And then we'll shift gears and start understanding kernel methods, including support vector machines. And from there on, we will move towards generative modeling. And this will include inference on Bayesian networks and Markov random fields, conditional random fields, restricted Boltzmann machines, and deep learning based generative models, including generative adversarial networks. And then we'll discuss about mixture models, including Gaussian mixture modeling and its parameter estimation. And various dimensionality reduction algorithms will also be discussed, and these will include principal component analysis, independent component analysis, non-negative matrix factorization, and so on and so forth. We'll also discuss about certain sampling methods like rejection sampling, Gibbs sampling, etc. Thereafter, we will discuss about sequential models such as hidden Markov models and their parameter estimation. And the last part in this study will be approximate inference, and these will include mostly Monte Carlo simulation methods. And we'll try to provide the codes in MATLAB and Python for these important algorithms. In the next session, we'll start with polynomial curve fitting, and we'll discuss about this regression problem in more detail. So please stay in touch, hit like, and subscribe to our channel. Thank you.